Dear students, we are handling the topic complex numbers. Complex numbers objective level 2 homework. Complex numbers objective level 2 homework. Let us start from first question onwards. First question, 1 plus I whole power 2011 by 1 minus I whole power 2009. One plus I whole power 2011 by 1 minus I whole power 2009. This can be written as 1 plus I whole power 2009 by 1 minus I whole power 2009 into 1 plus I whole square. Now you can write this one as 1 plus I by 1 minus I whole power 2009 into this is 1 plus I square plus 2I. Rationalize here. So 1 plus I into 1 plus I whole by 1 minus I into 1 plus I whole power 2009 into 2I, because 1 plus I square get cancelled. That is equal to here 1 plus I whole square. 1 plus I whole square whole by 2 whole power 2009 into 2I. 1 plus I whole square can be written as 1 plus I square plus 2I whole by 2 whole power 2009 into 2I. 1 plus I square get cancelled. 2I by 2 can be written as I power 2009. I power 2009 into 2I. So that is equal to 2 into I power 2010. That is equal to 2 into I square whole power 1005. So 2 into minus 1 whole power 1005. This is odd number. Odd number power becomes minus 1. Minus 1 power odd becomes minus. So this value is minus 2. Fourth option. Second one, if x plus iy, if x plus iy is equal to 3 by 2 plus cos theta plus I sin theta, x plus iy is equal to 3 by 2 plus cos theta plus I sin theta. 3 by 2 plus cos theta plus I sin theta. Then find the value of x minus 3 into x minus 1 plus y square. Now put theta is equal to 0 degrees. Theta is equal to 0 degrees. That implies x plus iy can be written as 3 by 2 plus cos theta value cos 0, it is 1, plus I sin theta meaning I sin it is 0. So 3 by 3, the value is 1 plus I into 0. Therefore, comparing real comma imaginary parts, x is equal to 1 and y is equal to 0. Now, substitute the values x equal to 1 and y equal to 0 in x minus 3 into x minus 1 plus y square. So 1 minus 3 becomes minus 2 into, of course, it is 0 plus 0 equal to 0. Value is 0. Second question, first option. Now third question, imaginary part of 1 by 1 minus cos theta. 1 by 1 minus cos theta plus I sin theta. 1 by 1 minus cos theta plus I sin theta, imaginary part we should calculate. So imaginary part only we need rationalize like this 1 minus cos theta plus I sin theta. So I mean multiply with 1 minus cos theta plus I sin theta. 1 minus cos theta whole square plus it becomes sin square theta. So imaginary part we need here. Imaginary part means I multiple. So write like this. This is sin theta by denominator 1 minus cos theta whole square plus sin square theta. 1 minus cos theta whole square becomes 1 plus cos theta plus sin theta minus 2 cos theta. 1 plus cos theta plus sin theta becomes 1, so 1 plus 1 becomes 2. 2 minus 2 cos theta. This is 2 minus 2 cos theta. So sin theta into 2 into 1 minus cos theta. So the value sin theta can be written as in the submultiple angle formula 2 sin theta by 2 cos theta by 2 whole by 2 into 1 minus cos theta formula 2 sin square theta by 2. 2 sin theta by 2 cos theta by 2 by 2 to 2 sin square theta by 2 cos theta by 2. Sin square get cancelled. So cos theta by 2 by sin theta by 2 becomes cot theta by 2. It is 1 by 2 into cot theta by 2, option, second option. Minus is given. Okay students, here we should multiply with, why? Because this is plus, we should multiply with minus. So minus 1 by 2 cot theta by 2, fourth option. Fourth question, 1 plus I into x minus I by 2 plus I plus 1 plus 2I. 1 plus 2I into y. This is plus I. Students, print mistake is there. Correct it. It is not minus. It is plus I. 1 plus 2I into y plus I by 2 minus I is equal to 1. That implies what is the value of ordered pair x comma y. By taking LCM of denominator, you should write like this: 2 minus I into 1 plus I into x minus I. Plus here this is 2 plus I into 1 plus 2I into y plus I whole by denominator 2 minus I into 2 plus I. 2 plus I into 2 minus I, that is equal to 1. That implies we should multiply like this: 2 minus I into x plus ix minus I into 2 minus I plus 2 plus I into y plus 2 iy plus 2 iy plus I into 2 plus I by a square plus b square concept 4 plus 1 it becomes 5, that is equal to 1. That implies multiply term by term, it becomes 2x plus 2ix minus ix minus I square x minus 2i minus of minus plus I square. This is 2y plus this is 4iy plus this is iy plus this is 2I square y plus 2i plus I square is equal to 5. Now 2i plus value minus value got cancelled. 2x, only 2x term is there. 2x minus I square becomes plus 1. So 2x plus x becomes 3x here. 3x next one plus 2ix minus ix becomes plus ix. Plus ix, this one completed, this one completed. Now 2y, that's all, simply 2y. This is 2I square y last. 2I square y, so 2y minus 2I square. This will be getting cancelled. Next one, 4iy plus iy, you can write plus 5iy. Plus 5iy plus I square 2I square, so this is minus 2 equal to 5. That implies, write like this, 3x minus 2 plus I taken common, within brackets you can write x plus 5y is equal to 5 plus I into 0. Compare real parts. Compare real comma imaginary parts, not only real. Compare real comma imaginary parts, both sides. That implies 3x minus 2 is equal to 5. 3x minus 2 is equal to 5 and x plus 5y is equal to 0. Taking this side, this minus 2 taken this side. So x is 7 by 3. This is 7 by 3. Substitute here 7 by 3 is equal to minus 5y. So y is equal to minus 7 by 15. So ordered pay x comma y you can write as 7 by 3 comma minus 7 by 15. 7 by 3 comma minus 7 by 15. First option. Now fifth question. The smallest positive integer n for which 1 plus I root 3. The smallest positive integer for which n for which 1 plus I root 3 whole power n by 2. 1 plus I root 3 whole power n by 2 is equal to dash. What is the value of 1 plus I root 3 whole by 2? Let us remember the value omega square is minus 1 minus I root 3 whole by 2. So 2 omega square you can write as minus 1 minus I root 3. 2 omega square is equal to minus 1 minus I root 3. So now you can understand 1 plus I root 3 is equal to minus 2 omega square. 1 plus I root 3 is equal to minus 2 omega square. Substitute here minus 2 omega square. Minus 2 omega square whole power n by 2. The smallest positive integer n for which it should be real. So we know that omega power multiple of 3 is real. So it is nothing but omega cube 1 concept. Put n is equal to 6 according to option. Here n equal to 6 is the correct value. If you put n is equal to 3, it becomes power of 3 by 2. It is not in proper way. So you can write 2 power of 3 into omega cube. That is equal to minus 8, which is real. There is no imaginary part. So n is equal to 6. Option 3 verified. Sixth question, if the square root of x square by y square plus y square by x square plus 1 by 2i into x by y plus y by x. Square root of x square plus y square plus y square by x square plus 1 by 2 I into x by y plus y by x plus 31 by 16 is plus or minus x by y plus y by x minus I by m. So what is the value of m? So whenever this square root is this one, this square is this one. So we should calculate this square and comparing the parts both sides. Now you should write x by y plus y by x minus I by m. X by y plus y by x minus I by m whole square is equal. Directly whatever the value he given, write the value. X square by y square plus y square by x square plus 1 by 2 I into x by y plus y by x plus 31 by 16. That implies now like a plus b plus c whole square formula, right? A square plus b square plus c square plus 2ab plus 2bc plus 2ca concept. So this is x square by y square plus y square by x square plus I square by m square. So minus of course it is plus I square by m square. So minus 1 by m square you can write. Minus 1 by m square plus this is 2ab formula 2xy plus y by x becomes only 2 into 1. Next 2ab this one and this one, so 2 minus 2i into x by minus 2i x by my minus 2i y by mx. So minus 2i you take common, minus 2i you take common, within the brackets you can write x by y plus y by x, minus 2i by m also, minus 2i by m xy and minus 2i by m y by x like this. That is equal to whatever the value he given, write the value x square by y square plus y square by x square plus 1 by 2i into x by y plus y by x. 1 by 2 into x by y plus y by x plus 31 by 16. Now x square by y square term get cancelled, y square by m square term also get cancelled. Now you can compare like this, 2 minus 1 by m square, right? This is real part, minus This can be understood as -1, -1 can be understood as I square. So 2I square, better to try to understand like this, students. So plus 2I by I square m square. Now this I will be getting cancelled like this. Now 1 by 2 he is asking into x by y plus y by x plus 31 by 16. We can convert this one in the term of plus 1 by 2i also. If you multiply and divide with 2i, denominator is there 2. So 4 by, here he is asking 1 by 2i. 1 by 2i into x by y plus y by x. Of course 1 by 2i is equal to 2 by m square. You can write, otherwise this part we can compare. Better to compare real part both sides. Compare real part. Compare real part. So 2 minus 1 by m square is equal to 31 by 16. Write like this. 2 minus 31 by 16 equal to 1 by m square. 16 2s are 32, 32 minus 31 becomes 1 by 16. So 1 by 16 equal to 1 by m square we got. So m square equal to 16. Therefore, m is equal to 4. This is the value. By comparing imaginary parts also, we will get answer. M is equal to 4. Of course, plus or minus 4 we get. Given only plus value. M is equal to 4. Now, seventh question. If Z1, Z2 are two complex numbers such that given condition is modulus of Z1 minus 3Z2. Modulus of Z1 minus 3Z2 whole by 3 minus Z1 Z2 bar over modulus is equal to 1. Next condition he given modulus of Z1 not equal to 3. Then what is the value of modulus of Z2? The value of modulus of Z2. Next step, given, you can understand this one, modulus of Z1 minus 3Z2 is equal to modulus of 3 minus Z1 Z2 bar. Modulus of 3 minus Z1 Z2 bar. Now squaring both sides. That implies modulus of Z1 minus 3Z2 over square is equal to this one also, modulus of 3 into Z1 minus Z2 bar whole square. Z1 minus Z2 bar whole square. Now let us remember the formula. Modulus of Z whole square is equal to ZZ bar. That means this whole square equal to this into this bar, this into this bar, like this. So Z1 minus 3Z2, this is a number, and this conjugate Z1 minus 3Z2 whole bar is equal to, in the similar way you write here 3 minus Z1 Z2 bar into, like this, 3 minus Z1 Z2 bar into 3 minus Z1 Z2 bar whole bar. That implies Z1 minus 3Z2, Z1 minus 3Z2 into this one can be understood as Z1 bar whole square minus separately you can write 3Z2 bar is equal to 3 minus Z1 Z2 bar into 3 minus Z1 bar Z2. Here you can understand Z2 bar, whole bar is Z2 and Z1 bar separate. This is Z2 bar, whole bar. There is no question of bar for 3 because 3 means 3 plus I into 0. Its conjugate 3 minus I into 0. So real part will not be changed. Directly you can write 3. Now multiply separately by term by term. Now Z1 bar minus 3 into Z1 Z2 bar minus 3 into Z2 Z1 bar is equal to 3 3s are 9 minus 3 into Z1 bar Z2 minus 3 into Z1 Z2 bar plus Z1 Z1 bar into Z2 Z2 bar. Now you can understand here 3 Z1 Z2 bar, 3 Z1 Z2 bar get cancelled. 3 Z2 Z1 bar, Z2 Z1 bar, this is also get cancelled. Z1 Z1 bar can be understood as like this, modulus of Z1 square. Modulus of Z1 square minus is equal to 9 we have. 9 plus this can be understood as Z1 square into Z2 square. Z1 square into Z2 square. This is Z1 bar minus 3Z2 bar multiplied. Here one term will be missed. Plus 9 here I did not write. I forgot to write here 9 into Z1 Z2 bar. Z2 Z2 bar. 9 into Z2 Z2 bar. So 9 into Z2 Z2 bar can be understood as 9 modulus of Z2 square. Z1 Z1 bar can be understood as modulus of Z1 square plus 9 into Z2 Z2 bar can be understood as modulus of Z2 square is equal to, this is also Z1 square dot Z2 square. Z1 square dot Z2 square. That implies these terms are taken that side. Z1 square. Modulus Z1 not equal to 3. She did not give properly. We should calculate modulus Z2. So write like this, modulus of Z1 square minus Z1 Z2. Modulus of Z1 square minus, this is modulus of Z1 square into modulus of Z2 square. Modulus of Z1 square into modulus of Z2 square. Now modulus of Z1 square into modulus of Z2 square. This is not visible properly. Here I am writing. That implies modulus of Z1 bar you can understand as modulus of Z1 square plus 9 into Z2 bar can be understood as modulus of Z2 square is equal to, here 9 plus modulus of Z1 bar is modulus of Z1 square and this is modulus of Z2 square. That implies, taken these terms like this, modulus of Z1 square minus modulus of Z1 square into modulus of Z2 square plus 9 into modulus of Z2 square minus 9 equal to 0. That implies, take modulus Z1 common, not square. Modulus Z1 taken common. Within the brackets you can write modulus of Z1 minus modulus of Z2. Now plus 9, if we take minus 9 and 9 Z2 square is there. This is Z2 Z2 bar 9 Z2 bar whole square exactly. Z2 Z2 bar plus 9, and this is 3 3s are 9 minus 3 Z1 bar into Z1 bar Z2 minus 3 into Z1 Z2 bar plus Z1 Z1 bar, yes, plus Z2 Z2 bar. So this is Z1 mod Z1 square into mod Z2 square. Taken this side, found we are not getting properly. Three minus Z1 Z2 bar into 3 minus Z1 bar Z2. Simply you left there. Z1 minus 3 Z2 into Z1 bar minus 3 Z2 bar, yes, is equal to 3 minus Z1 Z2 bar into 3 minus Z1 bar Z2 exactly. Z1 into Z1 bar minus 3 into Z1 Z2 bar minus 3 into Z2 Z1 bar plus 3 3s are 9 Z2 Z2 bar is equal to 3 3s are 9 minus 3 into Z1 bar Z2 minus 3 into Z1 Z2 bar plus Z1 bar, yes, Z1 bar Z2 Z2 bar. Next one, Z1 into Z1 bar becomes Z1 bar square. Here minus 3 Z1 Z2 bar gets cancelled. This is also get cancelled. Now we got modulus of Z1 square plus 9 modulus of Z2 square is equal to, this is exactly we have written 9 plus Z1 square Z2 square. Z1 square Z2 square. If taken this side the terms, Z1 square minus Z1 square Z2 square plus 9 Z2 square minus 9. Everything correct we have done. Let us calculate Z1 square common. Now this is 1 minus Z2 square within brackets. Minus 9 you take common. Now you can write here 1 minus Z2 square over modulus. Now it is correct. Equal to 0. Now again 1 minus Z2 square you can take common. 1 minus modulus of Z2 square within brackets and Z1 square minus 9 equal to 0. That meaning 1 minus Z2 square equal to 0. 1 minus modulus of Z2 square is equal to 0. 1 minus modulus of Z2 square equal to 0, or Z1 square is equal, Z1 square minus 9 equal to 0, so Z1 square equal to 9. Here whenever Z1 square equal to 9 we get Z1 equal to 3, which is wrong because he given Z1 not equal to 3. So this is correct. Which is correct here, modulus of Z2 square is equal to 1 is correct. Therefore modulus of Z2 is equal to 1 is the correct answer. 7th question, first option. Eighth question, Z1 plus Z2 by Z1 minus Z2 over modulus is equal to 1. Z1 plus Z2. Z1 plus Z2 by modulus of Z1 minus Z2 is equal to 1. Then what is the value of Z1 Z2? Like this you can write Z1 by Z2 plus 1 by Z1 by Z2 minus 1 over modulus equal to 1. if Z1 by Z2 is equal to IB, so we can understand this one as this is real part. If this is imaginary part, then modulus of 1 plus IB by modulus of 1 minus IB, otherwise IB minus 1. IB minus 1 equal to root of 1 plus B square by root of B square plus 1, that is equal to 1. So, Z1 by Z2 should be imaginary part. It is purely imaginary. Z1 by Z2 is purely imaginary. We have done the sum in level 1 classwork 18th question. The model you see. Level 1 classwork 18th question model. This is imaginary. Now 9th question. If Z is equal to T plus 3, Z is equal to T plus 3 plus iota into root of 5 minus T square. Z is equal to T plus 3 plus I into root of 5 minus T square. So T square less than 5 is given, T less than root 5. We can take a shortcut by putting T is equal to 0. Now find the modulus of Z plus 2 by Z minus 2 whole square. Modulus of Z plus 2 by Z minus 2 whole square. Put T is equal to 0. That implies Z is equal to simply 3 plus iota root 5. Now Z plus 2 by Z minus 2. Z plus 2 by Z minus 2 is equal to 5 plus iota root 5. The 2 whole square over modulus. 5 plus iota root 5 by 3 minus 2, this is 2. So 1 plus iota root 5. Now this is 1 minus iota. 1 minus iota root 5 whole square. Modulus meaning root of component square plus component square. If square is there, don't write root there. So write here as 25 plus 5 by 1 plus 5. 25 plus 5 becomes 30. 30 by 6 becomes 5. So 5 is the answer. 10th question. If alpha, beta, gamma and ABC are complex numbers such that alpha by A plus beta by B plus gamma by C is equal to 1 plus I, 1 plus iota, and A by alpha plus B by beta plus C by gamma equal to 0. A by alpha plus B by beta plus C by gamma equal to 0. Then find the value of alpha square by A square plus beta square by B square plus gamma square by C square is equal to dash. Alpha square by A square plus beta square by B square plus gamma square by C square is equal to dash. Now consider this one. Squaring both sides of 1. You can write this is by A plus B plus C whole square concept. A square plus B square plus C square like this. Alpha square by A square plus beta square by B square plus gamma square by C square plus 2 into alpha by A into beta by B plus beta by B into gamma by C plus gamma by C into alpha by A is equal to 1 plus I whole square is equal to 1 plus I whole square. The further step here I am writing, that implies alpha square by a square plus beta square by b square plus gamma square by c square plus 2 into, in these all terms, in a numerator and denominator, you are taking a common letter, that alpha beta gamma by ABC. Alpha beta gamma by ABC. Then, even though it is not there, we are taking common alpha beta. So denominator will get 1 by gamma and numerator will get c by c. So c by gamma in the similar way, b by beta in the similar way, a by alpha. So write like this: a by alpha. A by alpha plus b by beta plus c by gamma is equal to 1 plus I whole square becomes 1 plus I square plus 2I. 1 plus I square get cancelled. So it is 2I. Now this is 0 because he given the value, this is 0. That implies. So total value becomes 0. So you can understand now alpha square by a square plus beta square by b square plus gamma square by c square is equal to simply 2I. The value is 2I. Fourth option. Now 11th question. 11th question. If modulus of z less than root 3 minus 1, modulus of z less than root 3 minus 1, then modulus of z square plus 2z cos alpha, modulus of z square plus 2z cos alpha, given modulus z less than root 3 minus 1, let it be first equation. Now modulus of z square plus 2z cos alpha, modulus of z square plus 2z cos alpha, according to squat Gini equality, you can write this is lesser than or equal to modulus of z square plus 2 mod z cos alpha. Okay. 2 mod z cos alpha, otherwise 2 mod z into mod cos alpha you take. We know that the value, the range of the cos theta like this. We know that minus 1 less than or equal to cos theta less than or equal to 1. So cos alpha range, that implies always modulus cos alpha range less than 1. Of course less than or equal to 1. So maximum value is 1, simply it becomes 1. You write in next step, that is directly 1. So modulus z square plus, like this, modulus of z square plus 2z, modulus of z square plus 2z cos alpha lesser than or equal to modulus of z square, modulus of z square plus 2 mod z simply, that is lesser than or equal to, here the value of mod z he given as root 3 minus 1, so it is root 3 minus 1 whole square plus 2 into, this is also root 3 minus 1. This is lesser than or equal to root 3 minus 1 whole square, expand here. So this is 3 minus 2 root 3 plus 1 plus 2 root 3 minus 2. 2 root 3, this one plus and minus 1 get cancelled. So this is 3 plus 1, 4. 4 minus 2 becomes 2. So the value, maximum value here, 2. Less than 2. Less than 2 equal. 11th one, first option. Yeah. Less than or equal to. Also you can write. So maximum value only, less, the value always less than 2. 12th question. If modulus of Z1 minus 1 less than 2, modulus of Z2 minus 2 less than 1, that implies you should calculate modulus of Z1 plus Z2. Modulus of Z1 plus Z2. Consider modulus of Z1 plus Z2 is equal to. Consider modulus of Z1 plus Z2 is equal to. Write like this. It depends upon the given values you should write. Z1 minus 1, of course, plus 1. Plus Z2 minus 2, of course, plus 2. So, write like this. Modulus of Z1 plus Z2 is equal to, like this we can write, modulus of Z1 minus 1, write in a bracket, plus modulus of Z2 minus 2, write in a bracket, and minus like this. This one completed, this one completed. So this is plus 3. According to squat inequality, you can write this one as modulus of Z1 minus 1 plus modulus of Z2 minus 2 separately plus 3. So this is lesser than or equal to, this is 2 plus this is 1 plus 3. So total overall value is 6. The total modulus of Z1 plus Z2 value less than or equal to 6. Next, 13th question. You will look at it. 13th question, let alpha, beta be a real and Z be a complex number if Z square plus alpha Z plus beta is equal to 0, has two distinct roots. This is the main point for us. Has two distinct roots on line real Z equal to 1. Then it is necessary that given QE, given quadratic equation is Z square plus alpha Z plus beta equal to 0. Let Z is equal to X plus IY comma, not Z, alpha, two roots I am writing. Let two roots of this equation, let X plus IY comma X minus IY be roots. The two within brackets you should write distinct roots. For a complex quadratic equation, let alpha be a real and Z be a complex number. This is the quadratic equation, complex number. So you will get the roots in complex terms. So X plus IY and X minus IY we thought. Why did you think so? Whenever one complex number is a root of a quadratic equation, its conjugate is necessarily root. If one third is a root of a quadratic equation, necessarily other conjugate third is other root. In the similar way, you can think X plus IY and X minus IY are roots. Now, real Z equal to 1. This is also given. Read the question carefully. Therefore, you can write here 1 plus IY, comma 1 minus IY are roots. 1 plus IY and 1 minus IY are roots. Now, write product of roots. Taking product of roots. Product of roots is equal to here 1 plus IY into 1 minus IY is equal to beta. That implies not beta square. Yeah, beta is equal to 1 plus y square. We know that here, right? We know that every square greater than or equal to 0. But okay, leave it. Here I am discussing with you the condition y not equal to 0. If y is equal to 0, what will happen, sir? 1 plus I into 0 and 1 minus I into 0, 1 comma 1, 2 roots are there, that 2 real, and also here we given distant root should be there. So whenever y is equal to 0, there will not be distant roots. That is why you should think as y not equal to 0. So y, every square greater than equal to 0, it's okay, but here y simply greater than 0, that meaning y square greater than 0. So maybe 0.1 or 0.01 or 0.001 like this. So 1 plus, that meaning beta is equal to 1 plus like this. 1 plus 0 plus I mean. So 1 plus value. So beta is equal to 1 plus. That meaning range you can write. Range is equal to 1 open interval 1 should not be until infinity. 1 comma infinity. First option. Now 14th question. Integral 0 to 50 argument of minus z. Integral 0 to 50. Integral 0 to 50 argument of minus mod z dx is equal to argument of minus mod z dx is equal to let z is equal to x plus iy, mod z is equal to x square plus y square minus mod z, you write. Minus mod z is equal to minus of x square plus y square. We know that x square plus y square is a positive real number because every square is positive. We know that x square plus y square, x square plus y square is a positive real number. That implies minus modulus z is equal to negative real number we got. So negative real number. Now you can understand this one as minus of modulus of z is equal to minus of x square plus y square. Of course into maybe 1 plus I into 0. Plus I into 0. Theta is equal to tan inverse imaginary part by real part. That is the concept of theta. So 0 by anything, here 0. So theta is equal to, we got tan inverse of 0. Tan inverse of 0 meaning 0 or pi or 2 pi anything according to options. He given 0 also, he given 0 to, if z not equal to 0, he given, so argument should not be 0, argument should not be not defined, either first option or third, fourth option. For first option also will not get because we should not write 0. So tan inverse 0 you write pi. I am making you to remember that the argument value like this, minus pi less than or equal to theta less than pi or minus pi less than or equal to theta less than pi, less than or equal to, like this. So maybe pi or minus pi. If we take pi here, argument for minus 1 pi, I have taken pi. Minus pi if we take, okay, let us calculate now. Integral 0 to 50 pi into 1 dx. This is the numerical integration. It is called as definite integration. The integration which can be defined between certain definite limits. Students, try to understand 1 dx integral is x plus c, because the derivative of x is 1. In the similar way you can understand 1 integration is x. So pi taken outside, this is x, this is 0, this is 50, upper limit minus lower limit. So it is pi into 50, answer 50 pi. Of course you take minus pi also, but according to option it is correct. If you take minus pi, answer may be minus 50 pi. But he given only positive value. Now 14th question completed. Let us discuss the 15th question. 15th question. If p comma x are real, you have to calculate the value e power 2pi cot inverse x. E power 2pi cot inverse x into 1 plus ix. 1 plus ix by ix minus 1 whole power p is equal to 1 plus ix by ix minus 1 whole power p. Fifteenth question, given value write like this: e power I into 2p cot inverse x into, this is in general, write like this, minus I square plus x. For 1 minus I square I had written, minus I square plus x, denominator ix plus I square whole power p, that is equal to e power I into 2p cot inverse x. E power I into 2p cot inverse x into, here this is ix. In numerator you take common I within brackets, it becomes x minus I. In denominator you take common I within brackets, you can write x plus I whole power p. I get cancelled. Now take x is equal to r cos theta. X is equal to r cos theta comma y, 1 is equal to r sin theta. X is equal to r cos theta and 1 is equal to r sin theta. Now write like this: r cos theta by r sin theta is equal to x by 1. R get cancelled. So what is the value of cos theta by sin theta? It is cot theta. Cot theta is equal to x. Therefore, theta is equal to cot inverse x. It will be useful later. That is equal to, that implies I am writing e power I into 2p cot inverse x. E power I into 2p cot inverse x into, now we got the value x is equal to r cos theta and 1 is equal to r sin theta we thought. So numerator becomes cis of minus theta because cos theta minus I sin theta. Denominator becomes cis of theta whole power p. Whole power only p. That is equal to e power I into 2p cot inverse x. E power I into 2p cot inverse x into cis alpha by cis beta is equal to cis of alpha minus beta. So you can write cis of, this is minus 2 theta. Cis of minus 2 theta whole power p. That is equal to e power I into 2p cot inverse x. E power I into 2p cot inverse x into, this is general, not in e. Cis cos theta plus I sin theta concept according to De Moivre theorem, cos n theta plus I sin n theta. So you can understand this is cis of minus 2p theta. Cis of minus 2p theta. According to Euler's formula, you know that e power I theta is equal to cis theta. So that is equal to e power I into 2p cot inverse x into, this is e power I theta. This is e power I theta, meaning like this, e power I into minus 2p theta. That is equal to e power I into 2p into cot inverse x. Here you write plus, of course it is minus. Minus 2 theta becomes here minus 2 cot inverse x. I have taken common. So directly you can write minus 2p cot inverse x. Otherwise, this can be understood as theta e power 2p common, theta minus theta becomes 0. So this is e power 0, it is 1. 15th question, first option. Okay students, let us discuss from 16th onwards in next class.